my great pleasure to introduce our 14th annual Feigenbaum lecturer, Dr. Partho Sengupta of Mount Sinai Medical Center in New York City. As you know, this lectureship is named in honor of the first president and the founder of the American Society of Echocardiography, Dr. Harvey Feigenbaum. This annual lectureship is awarded to a young investigator in recognition of significant contribution to research in the field of echocardiography and the potential to continue at a high level of achievement. Dr. Sengupta certainly exemplifies this. He will present intelligent platforms for disease assessment, novel approaches in functional echocardiography. Before he starts, I want to remind you that there should be no flash photography during this presentation. Also, you will see the presentation best if you sit in the center area of the auditorium. Thank you for your cooperation. Now, please join me in welcoming Dr. Partho Sengupta.
Thank you, Dr. Palika. This is such an incredible honor. I would like to thank the American Society of Echocardiography, my mentors, my colleagues who nominated me for this incredible honor. And I would like to say that I'm hoping that this new presentation format would be a testimony to ASE's commitment to innovation and also highlight the vision of its founder president, Dr. Harvey Feigenbaum. At this moment, I'd like to disclose an amazing collaboration with engineering teams worldwide, media professionals, animators who have contributed to the content development for this presentation. Working with them has been an humbling experience and just made me realize that there is so much more to be learned and so much more to be done. In 1982, Dr. Feigenbaum wrote an editorial on the future applications of evaluation of ventricular function. Majority of his predictions have come true, thanks to the advancement in digital and the computer technology. The technical advances, however, continue further on and creating newer and newer opportunities. Today, I'm going to highlight how this accelerating change is going to create future opportunities in the field of functional echocardiography. And I'd like to start with an animation that I first saw in Chris Johnson's TED Talk at University of Utah and provides an estimate of what's an acceleration that we are seeing here in the field based upon the total amount of data that is currently existing in the world of computers and digital technology. If you see here, somewhere in the years of 2003, 2004, the amount of the data that is coming from the digital world exceeded the amount of the data that came from 40,000 years of human civilization. And the change continues exponentially. The same is happening in the field of echocardiography. If the number of publications from Scopus is an index of growth in the field, then you clearly see an exponential trend here. And if you would like to track the trends in the different fields of echocardiography, then you see here that in the 1980s, Doppler had the maximum number of publication growth. A change happened in the beginning of the 21st century. A number of publications in the field of parametric imaging like tissue Doppler, strain, displacement, velocity imaging started growing and exceeded somewhere in the years of 2003, 2004, all the other disciplines in echocardiography. And this highlights the worldwide enthusiasm in analyzing functional data sets. Pretty coincidentally, it was in 2003 I was introduced to the field of cardiac mechanics. And it was in 2004, right here in the YIA plenary sessions, I showed this video where an explanted heart specimen and a cross-sectional view of the left ventricle in its short axis revealed a curious counter-directional rotation of the speckles. You can see here the speckles are rotating in subendocardial region in one direction and subepicardial region in the other direction. This particular finding was subsequently confirmed using MRI. You can see here in an explanted heart, the motion in the subendocardial region is opposite to the epicardial region. So there is again a confirmation of a counter-directional motion in the subendo and the subepicardial region. If you construct the geometry of this counter-directional rotating fronts of tissues, what you end up is in a right-handed helical and a left-handed helical geometries of the subendocardial and the subepicardial region, which we know is the myocardial fiber geometry of a heart. And this emphasizes that speckles are not just random acoustic interference pattern, but they do have some basis also in the underlying myocardial geometry of the left ventricle. And this information has been quite useful, not only for understanding the movement, the peculiarities of the movement of the heart during the phases of cardiac cycle, but also for understanding the contributions of the different regions of the left ventricle to the longitudinal, circumferential, radial, rotational mechanics that we have seen exploding in the wave of research front in the recent era. In particular, for heart failure patient, assessment of multidirectional strains have shown that it's just not a single variable, but how the variables appear in cluster that identifies the heart failure syndromes. For example, in non-transperial dysfunction, you have reduced longitudinal mechanics with preservation, relative preservation of the other mechanics, and this is associated often with the phenotypic pattern of heart failure with preserved ejection fraction. Conversely, if all the mechanics go down, it forestalls transmural dysfunction, the LV dilates, and is associated with the phenotype of heart failure with reduced ejection fraction. Not only tissue mechanics in 2 dimensions, but also the data continues to increase because of the advent of 3D echocardiography. And this is a data from my colleague Gianni Pedrizzetti, where he has looked into the 3D strains and characterized the principal strains of the left ventricle over the surface of the left ventricle. And you can clearly see here also a helical pattern of the principal strain over the surface of the left ventricle. Just not tissue mechanics in 2D and 3D, we can now compute fluid mechanics from 2 dimensions. And here is an experimental data set where we characterize the flow mechanics inside porcine hearts. And we saw swirling fields of flow, or what is called as vortex formation, and characterize it during different phases of cardiac cycle. Since then, this kind of work has been translated to humans. And in this particular example, you can see the flow tracking of the contrast bubbles and the kinetic energy being characterized. As the flow transits from the mitral inflow to the outflow, it goes through the vortex formation. Never, ever during the phase of cardiac cycle is there any period of hemodynamic stasis. Flow mechanics can be characterized in multiplanar views. And here you can see the geometry of the vortex formation in early diastole has actually a toroid type appearance, just like a smoke ring is formed inside the left ventricle as it transits during the phases of cardiac cycle. All these visualization data sets has been met with a lot of enthusiasm. And here is an image that was featured on the cover page of Nature Cardiovascular Medicine for the entire year of 2012 and 2013. And here is a snapshot of the 3-dimensional flow fields of the same example, where you can see the kinetic energy inside the left ventricular chamber. The data is not existing just as single case examples, but has been translated into clinical research. And here are some preliminary data sets where we can see the incremental value of fluid mechanics, vortex mechanics in patients with heart failure, and also for understanding advanced therapies like cardiac resynchronization therapy. So we have so much of data that is coming from functional echocardiography. Tissue mechanics, fluid mechanics, how do we handle so much of data? What is relevant for the clinical field? If I just do a single study of a patient, this is the amount of data that comes from a single patient in an Excel spreadsheet. How am I going to handle all of these data? How do I look into each numbers? Should I just do an average? Should I do a standard deviation? Should I just ignore some of the numbers saying that they are not relevant? I'm reminded of one of my mentors who tells that we are moving towards an intelligent era. And my engineering team is going to beam up my mentor here, and let's ask him, what does he mean by intelligence in data? So Tim, if you have your coordinates ready, can you beam my mentor up here?
Hi, Partho. Thank you for beaming me in. I never imagined meeting you as a holographic avatar.
Such a great pleasure, Jim, to have you here. But tell me, are you from past, present, or the future?
Frankly, Partho, I feel like Obi-Wan Kenobi of Star Wars fame, but I don't think I'm dead, at least not yet. Recall Obi-Wan appeared as a computer-generated holographic avatar to answer important questions about the future, such as where to go, what to do, how to become a Jedi Master. How can I help you?
That's great. So, Obi-Wan Jim, tell us, where is ASE heading?
Partho, the American Society of Echo has a great future. However, it's about to be profoundly changed. ASE is currently in the information era, comprised principally of images, transitioning through the knowledge-based era, comprised of data. And now ASE is about to enter a totally new era of intelligence-based computing, comprised of data to event relationships. This era will be fully realized by 2020.
Wow.
A mere 7 years from now, and that's really impressive. In addition, there are 4 essential players in this new era of intelligent computing. First, expert users are the designated builders of intelligent algorithms. Secondly, ASE itself must continuously renew and enhance its knowledge base. Thirdly, industry must assume a totally new role as collaborator and messenger. And lastly, the medical community itself must accept the fact that computer-assisted intelligence is the most logical solution to higher quality, lower cost healthcare delivery.
I agree with you, Jim. I think we all are going to experience a very profound change very soon. I agree.
Partho, there's so much work to be done. I should be on my way. My new Millennium Falcon's waiting out in the parking lot. Goodbye, and may the Echo Force be with you.
Bye, Jim. Bye. Ladies and gentlemen, the recipient of the Outstanding Achievement Lifetime Award, Jim Seward. Thank you. So as Jim pointed out, winds of change have arrived. The biggest boon has been the merger of cloud automation with big data that are creating new avenues for intelligent and efficient platform for big data analysis. Crossroads are uniting and becoming one path. Let me illustrate some examples. The first example was the staging of the ASE reward study, a study where 1,024 patients were scanned